Hello and welcome to your introduction to this Phet lab. So you want to go to phet.colorado.edu. If you just search on PHET, you'll get there. And then you want to hover over simulations like so and click on physics right there like so. And then you're going to scroll down to Circuit Construction Kit, DC. Look for this little 5 there. That means it's HTML5. That means it's Java. We don't want to go there. So HTML5, and then you're going to go to this Circuit Construction Kit. Not this virtual lab one. That's got more stuff we don't need. So we're going to click there. And then we got to click here to start it, right? And once we start it, we're going to skip the introduction, and we're going to go straight to the lab. So that selects the lab. Now you got to click on it again. Okay, so this is the lab, and there's a few things. Let's see. So the first thing is labels over here. You can see how that says wire, battery, light bulb, resistor. If you uncheck that, now it doesn't have any labels. I suggest you leave the labels on. Show current. Let me pull a wire out here. See how that's got little, those are negative charges. So in electric current, we talk about the current going one way by convention. It flows positively, but the electrons actually move in the opposite direction. So there's the electrons, and then if you do this, they go away. And I'll show you that again once stuff starts moving. So let me construct the simplest of circuits here. There's a wire and a battery. And let's take a light bulb. Now the light bulb, see there's the one contact on the bottom, and the other contact is actually where the threads screw in. That's the way light bulbs are made. Whoa, I didn't want to do that. Jeez, what am I doing? Okay, there we go. Okay, so now that's connected. You can see it just kind of snaps, right? I gotta move that down. There we go, that's better. Okay, we can get rid of that. I'll have to read that later. Okay, so now I'm going to put this wire in here, connect that wire to the other side, like that, and then I can drag that wire down here, and I'll take another wire and connect it to the battery. The one thing about this Phet lab is the batteries do not run out. So there we go. So now you can see the negative charges. This is where all the negative charges are. So they're going out of the negative end and into the positive end. That's the way the battery works. But if by convention, we talk about stuff flowing from positive to negative. So if you do that, you're going to see the convention of current flow in the opposite direction, even though the charges are actually flowing one way. We talk about the current flowing the other way. So yes, that's a little confusing. You can thank, I think it was Benjamin Franklin who did that before we realized that it was actually the charges that move are negative. So that's that, and I'm going to move this out just a little bit to create some room. And values. So this is the another thing, that option you have is values. If you click on that, now you can see the values. This light has 10 ohms of resistance, and this battery has a voltage potential of 9 volts. That's 9 volts between here and here. So these two tools you're going to need. Don't worry about this one. So the first one is a voltmeter, and so the way a voltmeter works is that the black is negative and the red is positive, and you take the black and just stick it anywhere. Normally you'd have to find some bare metal or stick it through the insulation of the wire, but here you don't have to. You just stick it there, and then this one you get stick up on the other side, and you can see that's a 9-volt battery, right? So that's pretty cool. 9 volts across there. So the other thing is, and you can just leave that there, it won't hurt anything, is the amperes, which is the current flow. And this is an ammeter that you can just stick right in the circuit to watch. Or this is an ammeter that you can take this little doohickey right there and just hold it over there, and it'll show you the current that's flowing. And when we do Ohm's law, which is going to be part of this lab, you're going to have to be able to look at the voltage and the current and the resistance and everything like that. So that's the way that works. I'm going to put that aside for now. Put that back, and we'll get that away. Oops. Okay, I put that away. We'll just put those away for a moment. There. Okay, so there's a couple more components that you're definitely going to be using. If you click on something, and in the middle, you highlight the whole thing, and that trash can will get rid of it. Or you can click right on the end, and then those little scissor things will cut that connection. All right, so one thing you might want to put in is a switch. And now we have a switch in there, and the switch is open, which means it has infinite resistance. And then you just click it to close it, and now it has 0 resistance. You can actually set the wire resistance also, which makes it more real life because wires have resistance as well as everything else. So you can put a switch in to turn it on and off. The other thing is a resistor. So a resistor resists the flow of electricity. So I'm going to clip this, and I'm going to stick it on that resistor right there. I'm going to go like that, and then I'm going to go like, well, actually I'm going to put a wire there just to make it really clear that those are just separate things. Okay, so now we have a resistor, and that's 10 ohms. Each of these values, whether it's volts or ohms or whatever, you can click on that. Click on the thing, and you can change the value. And one just interesting thing to note, see these color bands on there? That's actually what tells you how many ohms of resistance this resistor has. Watch, I'm going to slide this slider, and the ohms are going to go up and down right there, and they'll also on these labels. I'm going to take the labels off for a moment. No, that's not what I meant to do. I'm going to take values off. There. Okay. So watch what happens when I slide this. Watch those colors. See the color bands changing? That's because those color bands actually indicate the level of resistance, the magnitude of the resistance that resistor offers. So there's a 0 resistance. The resistor has just a black band. Once you move into anything besides 0, you're going to see it starts to have bands. So that's what happens with that. And let's just add those values back on there. Okay. And what else? I think the rest of it is going to be for you to do in the lab, because that's kind of how everything works. Oh, let me show you one more thing. See down over here at the bottom. So right now we've got pictures. We've got a picture of a resistor, a picture of a battery, a picture of a light bulb. Those work fine, and a picture of a switch. Those work fine, obviously, and probably that's the way we want to do it. But you can use actual electrical schematic drawings instead. So if you click over here, see that? Now watch what happens to the drawing. Bam. So now this is what you'll actually see if you look at an electrical schematic. That's a resistor, that's a light bulb, and this is a battery. And you can see that over here the things also changed. So back to the battery. And then, so these are the main things we're going to be messing with in the lab. But there are other things over here that I don't know what that exactly is. It's a different kind of wire. Maybe it's the same wire. This is a fuse. If you put a fuse in a circuit, I'll just put a fuse in this circuit real quick here. If you put a fuse in the circuit, basically what happens is a fuse is a thin wire or some other device that is designed to handle a maximum amount of current and then interrupt the current flow so nothing gets damaged. So right now, let's see how much current we have. So right now we have 0.49 amps of current, which is well under the 4 amp limit of this fuse. What happens if I take this resistor and zero it out? The current's going to go up because there's less resistance to the flow of electricity. Okay, so now there's 0.9 amps flowing through the circuit. What if I take this light bulb and cut the resistance of that light bulb way down? Now, I just popped it. Why did I pop it? Let's see. Okay, so to reset the fuse, you click on the fuse, and this will reset it right there. Okay, so I lowered the resistance of this lamp to 7 ohms, and notice the current went up to 1.28. As I continue to, oops, that's the fuse. Let me get back to the light bulb. There we go. So now as I lower the resistance to the flow of electricity, see that current is going up as the resistance goes down. That's something you'll be calculating. And, oh, I went over 4 amps. The resistance was low enough that it went over 4 amps and it blew the circuit. And the whole point of that is that most components can only handle a certain amount of current. And and you want this thing to interrupt the current before you damage your light or your computer or whatever. So I think that's everything. And next stop is the lab for you.